So now let's see the third manipulator function, setw function. Also called setWidth, it is an output manipulator that is used to set the width, or number of columns, of a data output. The result would be right-aligned. For example, setw of 5, insert A. It reserves 5 positions for variable A, and places it aligned to the right end. Next is the setfill function. It is an output manipulator that is used to specify the character which fills unused columns within the specified width of a setw function manipulator. For example, let's declare int A equals 31. Then, the cout stream, setfill within single quotes asterisk, followed by insert setw function of 5, followed by insert variable A, would insert the value of variable A into 5 with output space. It would then fill the unused columns with asterisk character. Here is how the output would look like. Number 5. The setprecision function. It is an output manipulator that is used to control the number of digits a floating point number will display, including integer and fractional part of a number. If precision is to be set only for the fractional part, use fixed point notation. The fractional part will be rounded up to nearest value where necessary. For example 1. Cout, setprecision of 3, 1.579. It assigns 3 columns for the entire number, and prints the rounded up value, 1.58. This is the output. For example 2. Cout, fixed, setprecision of 3, 1.579. It assigns 3 columns for the fractional part, and prints 1.579. The exact value. This is the output. Example 3. Cout, fixed, setprecision of 3, 1.5799. It assigns 3 columns for the fractional part. Prints 1.580. The rounded value. This is the output. #include bits /stdc++.h. This is a special header file that includes all the header files. You don't need to remember and declare each header file for each purpose. However, namespace if any has to be declared separately. Character encoding. ASCII and Unicode. As learned earlier, the C++ compiler translates C++ code, or the source code, to machine language code or the object code. It's done by a sequence of conversions, from numeric values to its binary formats. Numeric data types like int, float, and double are converted into its equivalent binary formats, and stored in the computer's memory. The character data types are similarly stored as numbers in the computer's memory by character encoding. Character encoding is the process by which data types like char and string are internally represented by the computer as numerical codes. Every character is represented by an integer value, defined by standard agencies like the ASCII or Unicode. For example, ASCII or Unicode value 65 represents the character capital A, 66 as capital B, etc. Similarly, the value 97 represents small a, 98 represents small b, and so on. In ASCII format, each character occupies 1 byte of memory space. The character can occupy more than 1 byte of memory space in the Unicode format. Unicode efficiently handles both char and string data types. Unicode format is used to represent complex characters like Sanskrit, Chinese, Arabic scripts. The ASCII character encoding format. The ASCII, or American Standard Code for Information Interchange, is the earliest standard format for character encoding. It represents characters, or text matter, for electronic or digital communication. Since ASCII works with 8 bits, or 1 byte, it can process 8-bit, or 2 raised to 8, or 256 values. Therefore, ASCII defines total 256 character codes. You can refer to the ASCII values and characters online on any available link. ASCII character codes from 0 to 31, total 32, are control codes or non-printable codes. For example, the cancel key has ASCII code 24, escape key has value 27. ASCII character codes from 32 to 127, total 96, are representable characters. For example, $sign has ASCII code 36. Capital A has ASCII code 65. Small a has ASCII code 97. The ASCII code 32 represents blank space, 127 represents the delete control key. ASCII character codes from 128 to 255, total 128, are extended ASCII values for complex characters. For example, the euro symbol has ASCII code 128, British pound, 163, copyrights, 169, etc. The Unicode character encoding format. Unicode is the newer standard format for character encoding. It works with more than 1 byte of memory space, and hence, can usually process 8 bits, 16 bits, or 32 bits of values, with 2 raised to 8, 2 raised to 16, or 2 raised to 32, character codes respectively. A 16-bit Unicode uses 2 bytes for encoding each character, and a 32-bit Unicode uses 4 bytes for encoding each character. Refer to the Unicode chart online. Unicode is a superset of ASCII, and so the first 256 character codes of Unicode are same as that of ASCII. Unicode contains character codes for most written languages including left-to-right scripts like English, right-to-left scripts like Arabic, Chinese, Japanese, etc. Version 15.0 of the Unicode Consortium has defined 149,186 character codes, also including the graphic characters like emoji, the format characters, and the non-visual control characters. The backslash characters. They are character constants, used with the backslash symbol, to output certain special characters. The combination of a backslash with certain character constant is termed as the escape sequence. For example, \n is an escape sequence to print the new line. Few escape sequences, other than the \n. The backslash single quote is used to print the single quote. Similarly, we have escape sequences for double quote, backslash, etc. Next, let's write program 13. The requirement is to accept a character from keyboard and print its corresponding ASCII or Unicode value. So here is the program code. I save it as 13.cpp. On line 6, I declare a character variable named ch. In memory location, corresponding storage is reserved. On line 7, the user is prompted to enter a valid keyboard character. I type in capital Z. The cin command extracts it and stores it into the memory location, ch. Line 9 prints the ASCII equivalent of capital Z. It's 90. Lines 10 and 11 mention about the escape sequences I have used in the cout statement. Please have a good look at them. So with this, we come to an end of the chapter on input-output streams. In the next chapter we will discuss on conditional control structures and loops. Until then, take care and have a nice time.